Hi, my name is Surya. We are going to talk about the valence bond theory of nitrite. First, we will draw the Lewis structure by adding valence electrons and charges. There are a total of 18 electrons. After drawing the electron, we are able to see that we have 3 electron groups over here. This allows us to identify the electron geometry and the molecular geometry. The electron geometry is trigonal planar since there are 3 electron groups, while the molecular geometry is bent since it has 1 lone pair. Now that we know the geometry, we can also draw the VSEPR structure. We have a double bond here, a single bond, and 1 lone pair over here. Based on the structure, we know that the angle between the 2 bonding pairs is less than 120 degrees, since the lone pair to bonding pair repulsion is greater than bonding pair to bonding pair repulsion. We also know that we have 2 sigma bonds and 1 pi bond. Here are some different 3D structures for reference. Again, the electron geometry is trigonal planar because of the 3 electron groups present. Since we have 1 lone pair, the molecular geometry is bent. Again, lone pair repulsion is greater than the bonding pair repulsion, thus the angle between is less than 120 degrees. In this specific structure, you can see the 2 sigma bonds and 1 pi bond. Now we're going on to the box diagram. Since this is a bent trigonal planar geometry, we know that it goes through sp2 hybridization. We can skip the excited state and go straight to hybridization, which leads us to 2sp2. We also have a 2p left over here. And we start with the single bonded oxygen, which we can bring 1 here, forming a sigma bond, and another one here that is shared. And now we have to do the double bonded oxygen, which has to be hybridized. We can go straight into hybridization, skipping the excited state, since we only need since we know we only need 1 sigma bond here. And then we have the leftover 2p that we can bond to this 2p, forming a pi bond. Now that we have the box diagram, we can move on to the contour diagram. Between the nitrogen and the double bonded oxygen over here, we have 2 sp2 orbitals. This forms a sigma bond, and above and below the sigma bonds we have the pi bond. Based on the box diagram, we had 2 lone pairs for the double bonded oxygen over here, and for the single bonded oxygen we form a sigma bond as well as 2p orbitals, and we also have the lone pair. You can see that this repulsion is stronger than the bonding pair repulsion, which is less than 120 degrees. This is how you draw the contour diagram for nitrite.